I'm doing something that they taught us in math class, but I really don't understand.
Let me help you. Let me present myself. I am George Riemann, a well-known German mathematician who contributed mainly in differential geometry, but also made important contributions in number theory and complex analysis.
Whoa, so you can help me understand this topic?
Yes, I wrote my thesis about this topic.
Where did you study?
In the University of Berlin. I took courses of physics, mathematics, philosophy, and general education subjects. In 1851, I wrote my thesis on complex function theory, which includes the Riemann integrals that nowadays we use in our calculus classes.
So you can explain us how to do this problem?
Sure. The Riemann integrals are ways to approximate the area under a curve, forming the integral. They can be calculated by three different processes, which are the right rectangle approximation method, left rectangle approximation method, or midpoint rectangle approximation method. The midpoint rectangle approximation is a process that results in the closest answer compared to the real value.
And how do you know what approximation method you should use?
You can use whichever you want. Like I said, the midpoint approximation method is the closest to the real answer, but you can choose the method you want. Usually the problem tells you which one to use. Okay, so first we are going to solve the problem using the left RAM approximation method. Who volunteers?
Okay. The function is, as I said, 3x squared plus 5 and has the x1 of 2, x2 of 4, and the n is 4. To get delta x, we will do the x2 minus x1 over n, which is 4 minus 2 over 4, which gives us 0.5. First, on the table of values, we will have 5 x's to get the y values. The first one, since we start with the x1, will be 2, then 2.5, 3, 3.5, and finally 4 to end on the x squared, the x2. Then we substitute on the original function, 17, 23.75, 32, 41.75, and finally 4. Then we get the easy way to find the left RAM is to do delta x times all of these, which are the heights, to get the unit square. So we will do 0.5 times 17 plus 23.75 plus 32 plus 41.75 and until here, because we're only taking the values of the left RAM. From the right RAM will be on these. So we do the multiplication. .75, and the result is 57.25 units squared.
Okay, so now we will proceed with the right RAM approximation method. Who wants to show us how to solve it on the board?
And the first thing we need to do is to get delta x. And that is x2 minus x1 over n. So we have these values here, so the answer would be 4 minus 2 over 4, and that's equal to 0.5. So now that we got 0.5 and we must get from 2 to 4, we're gonna go 2, 2.5, 3, 3.5, and 4. Then we gotta substitute for each value. So this is 17. 2.5 squared times 3 plus 5 is 23.75. Now 9 times 3 plus 5 is 32. Then 41.75. And finally 53. Since we're gonna get the right RAM, we must do from here to here without this one, because this one's for the left RAM. So we add everything here. And multiply it by delta x. Now we plug it in the calculator. And the final answer is 75.25.
Unit squared.
Units squared.
Finally, we are going to solve the problem using the midpoint approximation method. Sophia, can you show us on the board?
Now we're going to get the midpoint RAM. First, with the delta x that we already have, 0.5, we need to get the midpoint between the first point and the second point. And the first point is 2. In our table of values, we had 2 and 2.5. So we need to get the midpoint in here, which is 2 plus 2.5 divided by 2, and we get 2.25. So this is going to be our first point. So in our table of values, we get 2.25, and now we just have to add the delta x to each one to get all the points. 2.75, 3.25, and 3.75. We plug this in the original formula and we get 20.18, 27.68, 36.68, and 47.8. Now we have to add all these and multiply it by the delta x. And we get 65, 65.56 units squared.
Great. Now you know how to solve an integral using the Riemann sums.
Thank you.
Sophie, wake up. Were you dreaming?
Yes, I saw Riemann. Now I know how to do the problem.